Hello, my name is Taloran Brown, and I will be taking you through my independent inquiry with the Junk Drawer Races competition. I completed my internship virtually, supervised by Richard Bishop, who is the DDSB Experiential Learning Facilitator. One of the programs he was running this year was the Skills Ontario Junk Drawer Races competition. The idea behind this project is to get students thinking and following the engineering design process while using materials that are easy to find and inexpensive. The informational PDFs provided by Skills Ontario are very dull and may be seen as a deterrent for some teachers to sign their class up. A group of us were tasked with creating slides that contain all of the information, but easier to read, and had a student-facing portion for teachers to present to their classes. Each of us had a different grade range to focus on. Mine was the grade 2 and 3 project, a gravity-powered robot. So why did I pick this project? I'm in the intermediate senior division with teachables in math and general science. I completed my science undergrad at the University of Ottawa and had the chance to work in a variety of really cool labs. From my experiences, I have seen that science materials, especially in the older grades, can become somewhat monotonous. This makes really interesting topics less exciting. I believe that science can be exciting and should be centered around creating and discovering, so when I saw this internship, I thought it was perfect as our part in this project helps achieve that. My learning goal for this internship was to be able to identify key components that make learning materials engaging for students, and feel confident in producing engaging and effective materials for a variety of age groups. From that, I set out to answer the inquiry question: what factors make learning materials, specifically slide presentations, engaging for students? I created 4 success criteria to help me measure whether I accomplished my learning goal. These criteria cover identifying what students pay attention to in presentations, factors that increase engagement, applying these factors to learning materials, and discovering strategies for transferring information into learning materials. To guide my inquiry, I followed Kolb's experiential learning cycle. I started in the active experimentation phase, while meeting and planning with Richard and the others working on the project. This also involved the research and determining how I was going to create the slides. The concrete experience phase was the actual creation of the slides, including feedback and revisions. The reflective observation phase involved observing how the slides were used, how students interacted with the slides, and analyzing any feedback on the slides. I am now finishing up the abstract conceptualization phase by solidifying the answer to my inquiry question and beginning to see its use in future applications. These are some of the considerations I pulled from my research when designing my slides. From an article on teaching science vocabulary to students, I took that it is important to provide relationships between new terminology and words that the students already know. It can also help students find the meaning of a new word when visuals connected to the word are provided. From an article on the principles of multimedia design, I highlighted the use of connected pictures or diagrams to go along with explanations. They also showed that fewer, more succinct words are often better and easier to understand than long, drawn-out explanations. From a chapter of a book on course and instructional material design, I learned some of the main criteria that instructors use to determine if a learning material is good. Some of these criteria are arousing the student's interest, drawing on prior learning, and taking into account different learning styles. The other 2 articles I looked at focused on designing engaging presentations. Some of the key points were making the message clear throughout, that the visuals should be related to the topic but not distracting, and having only a few key points for viewers to remember. To start the process of creating my slides, I searched for and looked through many different templates. Templates provide a cohesive look throughout the presentation, and if chosen appropriately, can add to the topic. I then read through the instructional PDF a few times, started pulling out the information that I thought was most important, and trying to put it in an order that flowed. I also had to come up with a timeline that I thought would give students enough time to complete each part of the activity while still staying engaged. I ended up organizing the main tasks into 4 days. I started creating the teacher section of the slides first, as that this way I would know exactly what information the teachers would have when I was creating the student slides. This involved looking at the curriculum and matching it to the challenge, as well as breaking down all of the background information, such as group sizes and submission requirements, into easy-to-read blurbs. I finished up with working on the student section of the slides, which was split up into the 4 days. Each day had a slide at the beginning which lets the teacher know what they need to prepare for that day and what materials they may need. The student slides were more focused on explaining the science behind the challenge, presenting the rules in a fun way, and providing inspiration to get students thinking. Due to the flexible schedule for teachers to implement the challenges in their classroom, as a group we decided that sending out a Google form as a feedback survey would be an appropriate method for collecting data. The idea was for the teacher to fill out the survey, but with input from the class. Some questions we included in the survey were levels of student engagement, how often they take part in STEM activities in the classroom, whether they have used an engineering journal before, how easy the slides were to use as a teacher, and how long students took on various parts of the challenges in comparison to the suggested timeline. There was also a comment box at the bottom for any additional feedback. The challenge ended up being released to teachers later than expected, and since the submissions aren't due until December, many teachers have not started the challenge with their classes yet. As a result, we did not have responses to the survey, and so we're not able to use that data. One teacher did post some pictures of her students' robots to a Padlet that Richard had created for sharing pictures. I wanted to have some sort of feedback from my slides to reflect on, so I ended up showing them to my cousin in grade 3, as well as some grade 1 to 3 students my sister tutors. Since the children were not actually completing the activity, it was hard to gauge the effectiveness of the slides. However, I did notice some common themes as we looked at the slides. Many of the children liked the robot graphics, and seemed to find the slides with diagrams and examples especially helpful. They also seemed very eager to try out the activity themselves, which indicates interest and engagement. After looking back at my success criteria, I would say that I was successful in all but one, applying these factors to materials in a variety of grades. I have started working on this as I have started creating materials for my final practicum. I am teaching 1 science and 2 chemistry classes, and so will use what I learned about creating engaging learning materials, specifically for science, to create a variety of materials for my classes. I will also be able to determine the effectiveness of these factors in older grades and adjust my strategies for creation if needed. I will then be able to use this internship experience and my practicum experience to shape how I will go about creating resources and different materials for my courses as a classroom teacher. Many of the articles I read also touched on the design of learning management systems and how the same principles apply. This will allow me to effectively use learning management systems with my classes. Here are the references for the research I talked about. Thank you for listening.